This is section 7.5 notes. For this section, you will need a calculator. So if you do not have a calculator with you, you're going to want to pause this video and grab a calculator. So for this first problem, we're going to be finding roots. Now in order to find roots, we need to look at what a root is. So a root is anything that has a radical sign in the problem. So for example, this radical sign here, this little number or letter is the index. It tells you what root it's going to be. So for example, this is the third root. This is the fourth root. This is the fifth root. The number underneath is the radicand. It's kind of like the base. It always is going to stay big. Okay? So for example, if I'm reading this, I say this is the third root of 125. This is the fourth root of 16. This is the fifth root of 32. So in order to do these on your calculator, you're going to type them in exactly as you see them.
Buses are here if you're planning on taking the bus home. Buses are here.
So you're going to type in 3 first, then you hit the second button up here, and you're going to hit this little caret key, the one that looks like an up arrow. And then you type in 125. Hit enter, and it'll tell you the answer is 5. So the third root of 125 is 5. Okay, this next one. And all this means is, so third root of 125 means if I take this 5, if I do 5 times 5 times 5 3 times, I should get 125. So the fourth root of 16, I hit 4, and then the second button and this up or caret key, and then I type in 16. Hit enter. So the fourth root of 16 is 2. To check that, I can do 2 times 2 times 2 times 2. Okay, or you can do 2 to the fourth power. Will also get you 16. Okay, now the fifth root of 32, so 5, then second, then the caret key is 2. Now to check that, I can do 2 to the fifth power, and it does check out. It does become my radicand. Okay, so that's how you use a calculator to find roots. That's how you plug them in. Next up, we are going to be converting. So we're going to convert something that has a fraction as an exponent to a radicand, or something with a radical on it. So the very first thing you want to do is make sure every part of this problem, every base has an exponent. So for this first one, it's 12 to the first power, a to the 2/3. For this next one, it's 64 to the first power, a to the first power. So go through and make sure everything has an exponent. So we're now just looking for exponents that are fractions. So 12 to the first power. 1, yeah, I can write it as a fraction, 1 over 1, but it's not already written as a fraction, so I'm just going to keep 12 as it is. A to the 2/3. That is a fraction. It's written as a fraction, so I'm going to start with a radical symbol, and I'm going to put A inside. Okay. Now to write this as a radical, the top number is going to go inside with the A, so this becomes A to the second. The bottom number becomes the index. That's the number on the outside. So that 3 goes on here. So this is really 12 times the third root of A to the second. It's just a different way of writing 12 times A to the 2/3 power. Okay, this next one gets a little bit more complicated. I'm going to distribute in, so I get rid of the fraction, or the parentheses. So I'm going to distribute in the fraction. So I have 64. 1 times 4/5 is 4/5. A to the 1 times 4/5 is 4/5. Okay, So now if I write these as radicands or radical symbols, my first base is 64. Now, again, the top number goes on the inside, the bottom number goes on the outside. So 64 to the fourth, so it's the fifth root of 64 to the fourth, times another radical symbol, because I have another part that has a fraction, a, again, the 4 from the top goes on the inside, the 5 from the bottom goes on the outside. So the fifth root of a to the fourth. That is your answer. So the fifth root of 64 to the fourth times the fifth root of a to the fourth. So we've converted from a fraction with an exponent to a radicand. Now we're going to go the other way. We're going to go from a radical symbol to a fraction as an exponent. So very similarly, where we wrote in all of the ones as exponents here, we have to make sure that there's a number on the outside and on the inside. So for this first one, there's missing a number on the outside, so I'm going to put a 1 there. Remember, 1's just my placeholder. So 1 goes on the outside here, so it's the first root of b to the third. Oh, sorry, I lied. This is going to be a 2. Whenever there's not a number on the outside of a radical, it's always a 2, because it's always the square root, which is what you've heard before. So this is the second root of b to the third, or the square root of b to the third. This one is the third root of 27 to the first power, d to the fifth. So I put in that 1 here on the 27. So now everything has an exponent and there's a little number outside. Exponent, little number outside. So now I can start rewriting this with fraction as an exponent. So I keep my base as b for this first problem. The number on the inside goes on the top, and the number on the outside goes on the bottom. So this is b to the 3/2 power. That's your final answer. This next one, you're going to have two parts. The first base is going to be 27 to the 1 is on the inside and 3 is on the outside, so 1/3 power. And then d is my next base. 5 is on the inside and 3 is on the outside. That is your final answer. If you have any questions on how we did any of these converting from radical form or from exponential form, please do not hesitate to ask.